Hey, so last time or maybe last few lecture, we talk about exception handling. So I hope you have some basic idea about why, how it works. And I spend lots of time, maybe this is my inefficiency in kind of getting the exception to work. I try to ask you a question to think about. Why do we need exception handling? Why can't we just use traditional programming, which is what you have done in programming in C, or maybe programming in Python, which you actually normally don't do exception handling. You just basically write the code. If you detect an error condition, you kind of reply. So what I did last time, it was a good example to show you how awkward it is for me to change here, change that, and then eventually I can get roughly equivalent information than the one I did using exception handling, which is the case saying that, oh, I'm actually trying to throw something, I have to pass everything through the function call instead of using the throw and catch clause. Okay, that is an introduction to the basic exception handling. So what I'm going to do next, there are three things. We're going to do it together. The first thing I'm going to do is I'm going to tell you that the real practical way and really good, powerful way to use exception handling. I consider this part is my strengths. Okay, it's normally you learn from the textbook about exception handling. There are situations which you really need to use exception handling in a more sophisticated way, which is help us to develop a very robust program with a what I call a collective exception handling. So what do I mean by collective? It means that I trigger my system once. A system could be a fairly complicated system, and such that exception information could be included in an object-oriented way, and such that we will be able to process that in a very nice way. And this is why we designed something called EE1520 exception, why we have our own exception handling methodology that's inherited from the standard STD exception, that's number one I'm going to teach you, because I found that this is I couldn't find any instructional material actually talk about this in a way I really feel satisfied. So I'm going to do that one thing. But the second thing is that this concept is going to apply to your homework assignment number 3. So essentially, for homework assignment number 2, you kind of done the first part. You kind of have a way to actually, okay, that's the JSON, somebody get on the bus, somebody get off, somebody lost his phone. You kind of can figure out that you can have a way to describe what's going to happen, okay? But then in a real implementation, the bus, the hospital, the EE building, they are distributed. They're not in the same program. They are distributed. So what I'm going to do is starting to introduce you exception handling, and yet we're going to apply that to homework assignment number 3 in a distributed way using JSON RPC CPP. Okay, and by the way, I hope you know that my instructional objective is bring the interest to each of the students in this class that you enjoy programming and not forcing you to do a lot of programming, which is make you hate programming at the end of the class. That's somewhat my philosophy in the instruction. So when I design the homework, I try to say, okay, I have to balance between give you enough practice that you will bring your interest and you know this concept exists. So for homework 2, I hope I kind of reduced. The homework 3, we're going to do the same way. We're going to make you taste a little bit about exceptional handling and then how to do that in a distributed programming way using J. So you're going to use the number 1 you're going to use is what we call the JSON representation about those events. The number 2 you're going to use what we call the proxy object. But number 3 is we're going to use is called mobile object, which is you try to move one object from one place to the other. I mean, for example, if I want to get off a bus in a distributed way, that means the bus is a server, is a machine. NCKU hospital is another server. So when somebody get off the bus, what does that mean? It means that the person object is going to be removed from the bus object and the bus server, not just the object, but also the server, and then move it to another physical server that's in NCKU. I'm going to show you how to do that. If you can do that, you know that, okay, your programming is touching the world. It's no longer just kind of simulation, everything in one single executable, that you're going to see multiple executable that in the future, on a campus like NCKU, we're going to have server everywhere. We're going to Raspberry Pi everywhere. We're going to IoT. Each of this is going to run separate program, and each of them will enable us to move objects, C++ object or JSON object, you name it, and from one place to the other. That's the second thing I want to start. I want to convey together. By the way, the good thing is that these 3 topics, we can put it together. And number 3, I would like to carry out for this is now we're going to carry into the final project. So whatever you did for your homework assignment number 3, this gives you the capability to handle a very realistic homework, final project. But then at the same time, start to convey to you that some of the final project idea that's going to using everything we have learned so far. By the way, we have a few things which I kind of skip, which I decide to lecture those things for the last 2 weeks. Okay, so just to let you know, because at that time you're already busy with your final project, and so then over there I can just do lecture. For example, why we shouldn't use multiple inheritance. For example, what's the memory layout for object, which you then understand how virtual function or polymorphism is really implemented. Those part are probably just knowledge and show you a few tools, but it's not going to be you don't need to do any like programming or tests for that. Okay, all right. So now I'm going to start a realistic exception handling. The first question I want to show you is this. By the way, what I show in this slide, it looks like it's a social media post. Okay, this could be Twitter, or could be Facebook, or could be Discord, could be whatever you name it. Okay, so essentially this is one of the communication mechanism that our society that we can exchange idea and share things with each other. So for example, over here we have what we call a post. This is somebody share a video or share a content, and then you share it on the server, or you share directly with your friend over line, and then other people start to make comment. Somebody can respond, right? There are multiple ways you can respond. That one way is you just simply click a reaction. You click a like or click a sad. Or you can reply by a message, another message from a person, and that response could be reacted with more reaction, right? I mean, for example, this particular content in this example, I have 2 comments. And each of the comments actually receive multiple reaction. Okay, of course, I can make this more complicated, but this is kind of the situation. Okay, so remember my methodology to do object-oriented programming, particularly in C++, is that we always first think about object before we think about class. We think about object before we think about class. Okay, so with this particular example, that we should think about, well, what is the object for this? How do I represent this with object? And you guys should know me good enough. You know that my answer is always this must be a JavaScript object notation. So whatever I did here, it can be translated into a JSON looks like this. Okay, by the way, you don't have to read it, but you can do that. Okay, you can translate any information into a JSON representation about that, including the reaction. For example, you can see I have the post, I have the where's the comment? Where's my comment? Oh, this is the link. I have a comments, and inside comments, I have where's the reaction? I must have a reaction somewhere. Yeah, I have a reaction. You see that I have a post. Where's my post? Somewhere. It's a message, and then I have a comment, and I have a reaction. Okay, so you can see that it's being encoded. I mean, by the way, you can use this if you know how I did this encoding. By the way, encoding is not that hard. Okay, encoding is tedious. For example, I mean, people will think about, wow, it's so complicated because sometimes you have a Facebook post, you could have millions of reactions, and you could have billions of people involved in a particular post. And when you think about the scale, you kind of get discouraged because typically you're thinking about, okay, if I want to handle a very simple thing, I feel okay. But if you want me to handle a object that's actually contain billion component inside that object, you kind of feel psychologically, oh, this is something beyond my control. I want to tell you, I want to convince you that's actually a wrong impression about programming. The nice thing about programming is that if you can translate something into a JSON looks like this, then you can handle 2 reaction versus 2 billion reaction. It's the same thing. If you can handle 2, I mean, look at what's the reaction. Let's look at reaction. Where's the reaction? Reaction is what? This is a bracket. I'm sorry, you probably have to see it very carefully. This is a bracket, and what's JSON bracket representation? Is an array. It's an array. So therefore, we have array of reaction. So as long as you have array, then essentially you have a 2 element in the array versus you have a 2 billion element in the array. From a programming perspective, they are the same. Okay, so the idea is that we're have a methodology we can describe a structure of information, and then the scale part is not what we should worry about. At least it shouldn't discourage us. So what you learned today and this quarter, I can tell you that you can apply to any number of the complexity that you need to deal with in real life. I mean, that's why I usually say, if you think about a company like a Facebook, when they define a post looks like this, to be honest, to design and implement this, it should take from scratch. I'm talking about from scratch. It shouldn't take more than 3 months. Once you learn C++ programming from this quarter, by the way, I'm not talking about have 40 years of programming experience, but if you have 1 semester of programming class, and then when you want to design your system with similar complexity, it's about 3 months. You can come up with something, but the difference between that 3 months versus what Facebook has right now is that Facebook, because they need to handle 2 billion users, and therefore they have to purchase, they have to have a infrastructure, that is a GPU server, whatever, to actually process most of the information. That's the only thing, because right now we probably only got We should I just speak louder? Okay, I think I'll come back. Got it back. Yeah. So that's okay. By the way, that's the one major difference between hardware and software. In hardware, if you have a 2 gates, you have a 2 billion gates. You want to put it into a chip. That's a huge difference. But in software, 2 element of array versus 2 billion element array, it's the same. Okay, I hope you understand. That's the power about doing programming. Okay, so I'm saying that okay, you can have a representation, looks like this, and then you can basically so outside from your I'm not going to use this. If you want to use Facebook, you use this. When you actually look at your Facebook ad, you're seeing an interface more or less looks like this. But internally, it's representing you as this. And what's the difference between these two? This one, I can easily do programming. This one, it looks nice, but it's not the level of information I can directly, easily write a program to represent. So this is usually we call front end. This is what we call back end. In the back end, it's all about JSON for today's web programming. In the front end is whatever interface that make it looks nice. Okay. All right. So having said that, I'm actually going to give you a challenge. So I have a post. And I look at my post from my smartphone. Okay, I look at the post. So essentially, I'm downloading a JSON for this post, right? Because I want to see this Facebook post. What does that mean? I have to download that JSON over here. Okay, I want you to think about this. What happened right now? I look at this comments or this particular post or this particular video. I want to click a like. I want to click a like. And you probably know when you click a like or when you leave a comment on a particular content, then other user on the same platform, they will be able to see it, right? Is that right? When you say post something, I mean, they're very easy. In this morning, when I post a line message informing all of you that I will be late because I'm actually walking from Yinping building on the whatever Guangfu campus and all the way here, and I was delayed in the middle because of some of the construction. So I will be late. But when I post online, then all of you actually receive it, right? All of you receive it. Okay, so my question is, how do you actually receive that information? How do you actually receive that information? Have you thought about this? Okay, so you can think about, I'm actually glad I have it here. Let's look at the real thing. I believe I can implement line. I have so many. Okay, don't look at some more information. Oh, thank you. Okay, you can see this is what happened, right? So I'm sending this message, and then you see I already got like a 4 reaction, right? 4 reaction. You guys click on your smartphone, and I can see it as well. So we're communicating. So even though from our perspective, that this is a recording about how we convey some information about whether I will be late for the class today. If you think about that, this is a lot of information being exchanged. And as I said, the information, what we're going to do is object being transferred from my phone to the server, and from the server push back to you guys' phone as well. And then you guys click reaction back to the server and then show it to me. Okay, of course with some delay. Okay, there are going to be some communication delay. That's another story, but we can into that very, very easily. But essentially you see that there are so many things pass here and there. And how do we actually make this happen? How do we actually make it happen? The answer, you already know the answer. If you know what I'm talking about, this must be a lot of JSON. is sending back and forth. Okay, so how do I send a comment to this particular post? Okay, this is the particular post. We call it EE1520 NCKU list, right? That's a post we all share and we all can leave comments. And how do we actually communicate? So I'm going to tell you how you can do it. I hope that after this, maybe in 2 or 3 class, you will feel very encouraged that you say, hey, I can build something better than Line. I can build something better than Facebook in terms of feature I want. Okay, that's the programming. When you do a programming, you want to make an impact. Okay, all right. So let me tell you that. Let me get back to my original example. I use this because not this one. I'm sorry. Here, this one. Let me tell you what we can do here. Okay, so this is the post. And as I said, I hope I convinced you I'm actually doing a JSON. Okay, so when I read it, when you walk into this room before you got my message, you probably don't see this, but when I send that message to you, you actually got it from your smartphone. And your phone is going to show a particular comments I just posted there, right? And then you're going to make a reaction. Okay, you're going to say, I love it or hate it, whatever. So when the whole thing push to your phone, it is a JSON just like this. I cannot change. What happened here? Okay. When you receive it, is something equivalent looks like this. It looks ugly, but this is the reality. Okay, when you receive a phone, it looks like this. But now, how do you send the reaction back to the Line server or Facebook server so others can see your reaction? The easiest way is the following. Okay, I suppose to ask you to think about the answer, but I'm going to give you a pass today. It's very easy. If this is the comment, you see that this is comment. Let's look at this carefully. Let me use my let me use this one. Hey, please. Okay. Let me use this one. It's easier. See, here is a comment. Comments. Okay, can you see it? Probably not. I hate this. Okay, fine. I will use Emacs. I will use Emacs. My best friend is still Emacs after 40 years of programming. Okay. Okay. This should be already in the directory, but now you see that this is the whole JSON, but I'm actually encoding so we can see a little bit better. Okay, so I'm going to move my own picture over here. I don't want you to be here. Okay, so look at here. I have a wait a minute. Where's comments? Oh, comments is here. Okay, this is the comments. And it's an array. So let me just show you what is a comment. This whole session is about comments. Let me see. Wow. I have to go down a little bit. Actually, a comment is fairly complicated. Okay. Let me just cut the comment part out. Okay. I know what I want to do. So that's why you need the two style string. It makes much better. Okay. No, I don't want this. Okay. Now this is the comment. Let me try to parse it so you know what's going on. So the comment, let me go back to the A. So comment is an array. So I'm going to click it like looks like this. So this is comment number one. Let me see, where's my comment number two? It must be started with an ID. Where's ID? Maybe I don't have, maybe this one I only have a one comment. I'm sorry. And this is a comment with the ID. That's why now we're trying to make it the JSON friendly. It's a from Felix, from Peter. And then this part is a message. And this is a creation time. And then this part is the part I want, is a reaction. And then the reaction has data, has an array. And each of this is a reaction. So each of the reaction also has a from, has a type, has a creation time. That's one comment. And then this is the second comment, second reaction. From, this is a from. This is the type. You can see that after I done this, you can see the structure. And it basically say, hey, this particular comments totally has two reaction. Okay. And then this is the second comment. Okay, now I found the second comment. From here is a second comment. And again, I'm not going to finish the whole thing. Maybe I should finish the whole thing. It's probably easier. This is a from. Again, I have message. And again, I have a created time. And then again, I have a reaction. And again, reaction is an array. And this array, again, has two reactions. The first one is from. The second one is typed. The third one is created. And then I have the second reaction to the second comments. Again, is a from. And then type, created. And then this is the end of the reaction part, which is the two. And then there's a two comment. And then the rest is actually belong to the rest of the post. I can get rid of this. Okay. So let me see if I can make it a little bit better. So you can see that it looks very complicated when I first show you in the slide, but if you can break it correctly, you can see that there is a structure and they're following exactly the same structure. It's basically comments and you have an array. Each of the comments, let's look at just one comment. This part is considered the first comment. It's an array, but this one is the first comment. The first comment has two reactions. The reaction itself is an array. Okay, so it's an array of the comments, and you have a bunch of key value pair. You have ID, you have who actually make the comment, what's the message, what's the created time, and then you have a reaction. If you think about that, that's pretty much everything we care. Okay, who actually did this? When you did it? What did you say? and then what were people's response to that? We can use this to represent. Okay, so that is a reaction. Okay, so now what I'm going to say, okay, assuming you got this over your smartphone, now you want to add another reaction. What should you do? What should you do? Okay, so one of the very easy way to do it is this way. Assuming Reacher want to make a comment. So what should you do? Reacher is, okay, I'm going to copy this part. Your TA did this. I have to put a, no. Did I do this correctly? From Oracle, where's from? Oh, here, yeah, it's correct. So the from should be Richer, your TA here. And VSID is, I would just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, just fake one. And the type of the reaction, his reaction is say hate. Okay. And the time is going to be what day is today? 2025. Today is what? May 15th. And what time is right now is 10 o'clock. 10:50. Okay, you see that by inserting an element into an array. Now what you got, okay, I'm going to just get rid of this unnecessary comment, comma. Okay, so you can just simply modify the JSON. Now you have a content which is including that particular reaction. Okay, and once you, so this is actually really happening back end. When you actually click a reaction, click a like or whatever, 8, then essentially what happened on your phone is that I'm actually constructing a JSON looks like this. And then what I did is I just send this JSON to the, I would say, I will send this JSON to the server, and then after the server receive it, they will update this. They will update this, and then other student can actually see your reaction. Okay, so that's actually one way to do it. Okay, any question? I'm just using a very simple way to tell you what happened in object when you want to add a reaction to a post. Any question? You should ask 2 questions. First question is that, wow, there is a delay issue because this is going to be huge. This is a large information. Sometimes this might have a billion reaction. And then if I just add it to this, I might not. Your 4G or 5G bandwidth is not going to serve you very well. So you have to think about what is the smallest amount of information that you need, okay? The second question you should ask yourself is what happens if multiple students simultaneously we want to add a reaction, right? There are 2 questions. Let me actually write it down. This is an important question. Think about this in a reality, you have to deal with this. How do I insert a slide? Yes, I want to insert a new slide. The 2 questions, number 1 is the scale of the post might be pretty big. Okay, the whole thing, the post, including comments, including reaction. The second part is multiple user simultaneously want to update. Okay, so those are the two issues I like to share with you what you can do with this. Okay, if you have a way to update a reaction, if you have a way to deal with the scale, if you have a way to handle multiple users, you're pretty much already done whatever Facebook is done for you already. If you think about that, if you can do that, you should be able to do a very, very practical and useful scalable system. Okay, so that's the two things I'm going to tell you. So first, let's worry about scale. In fact, I'm going to kill two birds with one stone. I'm going to solve this two problem together. First, I'm going to do this. Let's go back. Let's go back to my Emacs. Okay, let me write it to another one. I will write to another. Okay, so what I can do, I'm going to shrink everything that's unnecessary, and then I can make it to work. So this is what I'm going to do. I'm going to get rid of this from. I'm going to get rid of message. I'm going to get rid of reaction. And inside the reaction array, I'm going to get rid of this one. And then only this count become 1. And then I'm going to get rid of the second comments. And then over here, I'm actually going to do this. Okay, so what's the difference between now what I showed you here and the one I showed you earlier? So what I showed you earlier is a representation of a complete post. So basically, it carry out all the history about everything regarding this conversation. But over here, I shrink only contain the new updated information, which is the reaction. But the good thing is I still have a pointer or whatever ID. That's why we have ID. This ID is called comment ID. Okay, this is a comment ID. The comment ID has 3 elements. By the way, this is a Facebook notation. So Facebook, when you look at a post, it must have first has a page ID or community ID. And the second one is called post ID. The third one is called comment ID. So for every single post internally, of course, if you look at your phone from the app, you cannot see it. But if you can view the source about whatever information you got, you actually see that your information has been encoded with the 3 parts ID that concatenate together. So with this, I know that the whole thing, whatever below, is for that particular post, for that particular page, for that particular comment. And then I'm just saying that, okay, I have a one reaction. This reaction is going to be newly added to the server. Okay, so technically, if you think about that, as a server, I only really need this part. And I can actually add it to that. So this actually solved the scale problem. So which means that when you want to see the whole conversation, you download a lot of information. In fact, even for Facebook or Line, you can see that they only show you the last part. They only show you partially about the newest comment, newest information. And the earlier one, you have to actually scroll a little bit harder, which means that your client, which means your phone, is going to pull out more information from the server. So now from now on, whenever you want to look at Line, you actually see that it's all JSON is happening between your machine and the Facebook or Line server. But this essentially, when I update, because I want to add a comment, add a reaction for this one, I only need to encode this part. So this becomes very small. So when you send to the server, it's a very small package, and then they will be able to include it into the complete version, so such that it will record your new reaction. So that's number one. Number two, multiple people are doing this, right? Remember, the second question we need to think about is, not this one, I'm sorry. That we want to make sure that multiple users can simultaneously update, which means that in this room, we have a 56 student. You all send a little update. You send your own reaction. Some of you hate, some of you like, some of you love, and some of you might be leaving something else over there. And then essentially, you can imagine the server will receive a tiny JSON, like what I showed you earlier, and collect it from all of you. And what the server needs to do is merge all of this together. Okay, if you have a 56 reaction, then the server will just basically update the original post, which is the post, like this one. And I'm just basically merge each of the new element into here, in such that now you have a post that's reflect all the reaction or all the comments you have collected. Okay, so that's technically should happen, and this is reality how you can implement that. Okay. Okay, any question? All right, I'm going to take a break here, and we'll come back in 10 minutes.